So we have that the formula for the acceleration is equal to minus the amplitude times omega squared times cosine of omega times the time plus phi. But we know that the acceleration is maximum when it is on the limit. So we know that this is equal to 1. And the formula of the acceleration is going to be equal to minus the amplitude times omega squared. And we know that omega is equal to the square root of k over the mass. So if we substitute this on the formula of the acceleration, it will be equal to minus a square root of k over m square of this term, and this is going to cancel out, and it is going to be equal to minus a times k over the mass. And from this equation we can isolate k. So the new equation is going to be equal to the mass times the acceleration over the amplitude. So if we substitute this formula, we are going to have this. And if we analyze the units, we have kilograms times meters over second squared over meters, and we know kilogram times meter over second squared is equal to newtons, and it is going to be newtons over meters. So the answer is 1.7101 newtons over meters. So once we have the value of the constant of the spring, we can substitute the value on the equation, and it is going to be like this. And we know that the units of omega are radians over seconds. So the result of this equation is 3.15 radians over second. Okay, so now we are going to calculate the position, and we know that phi is equal to 0, so it is going to cancel out. And if we substitute by all the values that we previously obtained, we need to remember that we are using the values when the time is equal to 1, and the result of this equation is going to be minus 0.12 meters.
Okay, so to obtain the velocity of the cell phone when the time is equal to 1 second, we need to use this formula, and then we already have the values of the amplitude and the angular velocity, and so we only substitute, and it will be like this. And the result will be equal to minus 0.0225 meters per second. So to obtain the restoring force of the string, we need to use this formula, n Vx, and we're going to use the value that we previously obtained in the position of x when the time is equal to 1 second. And so if we substitute, we have that the constant of the string times the position of the object. Well, and here, as we have newtons over meters times meters, we will be cancelled out, and then we will have 0.2 newtons. To obtain the period, we use this formula, and then we substitute the values that we previously obtained in previous exercises. And if we substitute, it will be like this. And well, if we analyze the units, we can see that the mass is equal to kilograms, and the units of the constant are newtons over meters. And then if we simplify this, we will see in here that at the end we obtain seconds as a result. And then solving this equation, we have that the period is equal to 1.99, or equal to 2 seconds. To obtain the frequency, well, we divide the 1 over period, and as we know that the period is 2, we just substitute in the formula, and this will be equal to 0.5 hertz.